And let's move on to the next session, which is about visualizing the radiosonde data. So radiosonde data, you can see the example from MPAS-A here. So I think some of you may be familiar with this graph. This is a Skew-T log P diagram. Some of you may not have learned it, but it's not, it doesn't matter because I just teach you how to visualize the data. So, okay, so radiosonde data is like every 8 o'clock in Hong Kong, we will release the Hong Kong Observatory will release a balloon, and then to record the weather data in the upper atmosphere. And so these are the sounding data or radiosonde data. So we will plot the Skew-T log P diagram in this session for those sounding data. And these are the libraries that we need for this session, the MPAS-A libraries. And then read the sounding radiosonde data. So the data I've taken from is from this website. So you just visit this website and see what it is. So this is a website from a university, and then it collects all the radiosonde data all over the world. So it's like here, and then maybe Skew-T, and then today maybe. So if you choose the Kings Park station here, you can see this is today's, yeah, I think it's today, right? This is May 24th, yeah, it's today. So this is the data that we have today. And then I just choose the date of the sounding of data of this date here. So you read it and you can see here we have pressure and height and temperature, dew point, temperature, etc. And we don't need all of them to plot a Skew-T log P diagram. We just need something maybe like a pressure and then the temperature and then the dew point temperature. And we also need wind speed as well. Like this is the direction, and then this is the, I think this is the wind speed. So let's do some post-processing of the data first. Here we want to convert the unit of these things. So so this pressure column has a unit of hectopascal, and these two columns, temperature and dew point temperature, has a unit of degrees Celsius. We add these units to these columns first, and then store it into a variable. And also for the speed and direction, we also do this as well. And here it is a function to convert the speed and the direction of the vectors to U and V components. And the next step we need to calculate is the lifted condensation level. So lifted condensation level is basically the level, because a parcel will rise diabatically when it does not saturate it, right? So when it meets a certain point, it will be saturated. So this is the lifted condensation level. And this is the function supported in MPAS-A that helps you to calculate the lifted condensation level from the data you give it. And so if you just run this cell, you can see the lifted, this LCL, the pressure level and the temperature of this LCL. And then this parcel profile is basically how the parcel is dry adiabatically lifted or moist adiabatically lifted after the parcel have reached the LCL. So you can see this profile after we have plotted the Skew-T log P diagram. So in here, we use a function called a Skew-T function supported in MPAS-A to generate the Skew-T log P diagram. So we first create a figure, and then we apply the Skew-T function here, and then it generates an axis. This is actually an axis object. We usually use AX to represent an axis object, but in this tutorial, So it's actually from the example of MPAS-A. So we use skew to represent the axis objects here. And then we apply some maybe the temperature here. We draw a line plot in this axis object. And here we also plot the barbs here. The barbs will be located at the right-hand side of the plot. So yeah, maybe, yeah, let's draw it first. So in here, you can see the red line is red. So it's the temperature, it's the observed temperature from the sampling data, and the green line is the dew point temperature. And then here, the right-hand side of the graph is the wind barb. So this is the horizontal wind, yeah. So basically it means this is blowing like easterly, right? So this is from here. So these are the easterly wind. And we set the limit of the x-axis and y-axis here. And for this one, this is the black dot here. And this is the level of the lifted condensation level. So we just add the, you can see from here, this is a black dot here. This is the lifted condensation level, and here is the parcel profile. Oh, sorry. This is the parcel profile. So we have specified it here before, right? So this is basically how the parcel lifted adiabatically. So here it follows the dry adiabatic, and then here it moist adiabatically lifted up. And then here for the shaded regions, we have CAPE. Well, if you're interested, you may look at some of these websites I have provided you. So for example, in here. Oh, okay, the sharing screen button is here. So you can see here, general Skew-T Lockby diagram contains these information like temperature and so on and so forth. And yeah, and this website as well. So you can see from here, Skew-T Lockby diagram needs to contain the dry adiabatic lines, and then the moist adiabatic lines, and then the mixing ratio line. So here I have missing some of the lines, and you can see here, this is basically the temperature scale, the lines of the temperature, constant temperature. And then these are the isobars, yeah, the constant pressure. The horizontal lines are the constant pressure lines, and then the skewed lines are the constant temperature. And then I also need to add some of the adiabatic lines here. And actually these lines are provided by MPAS-A. So when you do this, and then press tab here, the tab button basically helps you to see what functions are supported by this object. So you can see here, plot dry adiabats. Yeah, we just do this, and then we also have mixing lines, and then we also have moist adiabats. So after you have added these ones, you can now see that these are the orange lines are dry adiabats, and then these blue lines are moist adiabats, and then these green dotted lines are the mixing ratio. So you also need these lines to make a Skew-T diagram complete. And of course, you can also change the density of the lines by checking the API of it. For example, here I type a question mark. I check the API of this function, and you can see here I can specify the temperature range of these lines. And we didn't specify here, so it just uses the default range from our graphs. So the x-axis, the temperature range here. Yeah, so here we need to specify like if we want to make the line denser, we can do something like specify the T0 parameter. And for example, we want to change it maybe every 5 degrees Celsius. Well, it won't work actually. Well, I just know this because if you check the API in details, it tells you that it needs to be the temperature values in Kelvin. And because this is a MPAS function, it also needs to have a unit in this data array. So you will want to, first of all, change it to so you need to plus 273.15 to change it to a Kelvin unit. And then you also need to apply, you need to tell the function that is in the unit of Kelvin. So you only need this if you are using the MPAS function. So here, yeah, you can see the lines are much more denser because it ranges from -40 degrees Celsius to 50, and then I plot it every 5 degrees Celsius. So these are the functions that you can use in this here MPAS function.